Hello everyone. In this lecture I shall discuss the exact differential equation. Okay. As we have discussed in earlier lectures, the standard form of differential equation of first order and first degree is mxy dx plus nxy dy is equal to 0. Let it be my equation 1. Now this equation 1 is said to be exact if the left member means this is a complete differential. Okay, is a complete differential. That means I can say the left member here is d of something, you say, okay, is a complete differential, right? So this is the left member, this is the left member, this is the left member, and this is a complete differential. Okay, complete differential, right? Then only this is said to be a exact differential equation. What is the basic definition of the exact differential equation? Okay, but generally the students are confused this definition with the condition of the exactness. So next, coming to the condition of exactness, before that let me to introduce myself. Professor Susanta Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra University of Technology, Burla, Odisha, India. Now without much delay, let us now discuss the condition for exactness. So now the condition for exactness of this differential equation is your del m by del y is equal to del n by del x. Okay, del n by del x. So don't be confused with m and n. Okay, means this variable with respect to the opposite variable, and this variable is with respect to the opposite variable. If this condition hold, then this is called the condition for exactness, and this is a necessary and sufficient condition. Once exact, then this condition will hold. Once this condition will hold, then also exact. So let us see some examples by means of the condition as well as by means of the definition to understand the exactness of the differential equation. Now consider the following examples. X dy plus y dx is equal to 0. We can easily write it d of xy is equal to 0. Okay, so by definition it is exact. It is exact, is not it? Because the left member here is a complete differential. If we think of the condition, if I take this is my m, okay, or if I can take this is my m and this is my n, because dx is here, so del m by del y is here 1, and here del n by del x, this is here also 1, so therefore exact. Okay, now coming to this differential equation, it is d of x by y is equal to 0 by inspection. Okay, by inspection, so it is exact, it is exact. Okay, now coming to this differential equation. Okay, if you say this is m, if you say this is your n, okay, then del m by this variable with respect to this, del m by del theta is 3e to the power 3 theta, and my del n by del r, okay, this with respect to this, del n by del r is 3e to the power 3 theta. Okay, so you see this is equal to this, therefore exact by the condition, exact by the condition. Okay, so choosing m and n, that depends upon us. Okay, so here also we can choose m and n different. If I choose this is m, if I choose this is your m, okay, and this is your n, then also fine. Then what to choose or take it? So this m, your del m by del x we have to find, because this with respect to this, and this with respect to this. Okay, so your del m by del x is equal to your 1. So your del m by del x is your 1, and which is your del n by del y. Okay, this is your n now, so del n by del y is your 1, right? That means this m with respect to this variable and this n with respect to this variable. This is my intention to say. In that way we will be able to check the condition. So this is the beautiful example Okay, so this variable with respect to this m with respect to this, and here this n, okay, this n with respect to this variable r. This is the thing. Now let us see the general rule for solution. Now coming to the working rule of exact differential equation. You are given a differential equation, let it be my equation 1. First you check this condition. If yes, then it is exact. If it is x, then it is exact. Once it is exact, then the general solution is like this. It is mxy dx integral. You treat y is equal to constant. Y is equal to constant. Plus in your n, you find the terms independent of x. Okay. Plus your ny dy. Ny dy. Okay, means here terms independent of x. Okay, then in n you collect those terms which are independent of x and which is equal to your constant. Okay, this is a constant. So this is the general solution, right? Once the equation is exact, then it is the general solution. So let us see some examples. So coming to one example, so the differential equation is of this form. Let it be your m and let it be your n. Okay, so the differential equation, the given differential equation, is of the form m xy dx plus n xy dy is equal to 0 with mxy is equal to your y cos x plus sin y plus y, and nxy is equal to your sin x plus x cos y plus x. Now we check the condition. Now del m by del y, if we differentiate it with respect to y, treating x as a constant, then we have it is cos x plus derivative of sin y is cos y plus derivative of y is your 1, and del n by del x is equal to and del n by del x is equal to, you differentiate it, it is cos x and it is your cos y is constant, it is your cos y and it is x is your 1. Clearly del m by del y is equal to del n by del x. So therefore here let it be your given equation 1. Therefore equation 1 is exact. Thus its general solution is mxy dx treating y is equal to constant plus integration of ny dy is equal to c. This is term free from x. Okay, c1. So now you see mxy dx, you write it integration of this with y is constant. So this implies here y into integration of cos x dx plus sin y into integration of dx. So this is your m dx. Okay, now plus ny dy in n terms free from x. So this is not free from x, this is not free from x, this is for also not free from x. So there is no terms, means 0, dy is equal to my constant c1. There is no term free from your x. Okay, because no term free from x, independent from x. Okay, so that means your y into integration of cos x is sin x plus it is x sin y. There is some constant in the left hand side and right hand side there is a constant, so it is c. So this is my final answer. Okay, now let us solve one more example. Now consider this is the problem. So here you can write it by inspection d of xy, and by inspection you can write it d of tan inverse y by x is equal to 0. So this implies completely it is d of xy plus tan inverse y by x is equal to 0. So integrating both sides, in the left hand side it will be xy plus tan inverse y by x is equal to your c. This is your answer. Okay, or you can find m dx plus n dy equal to 0, and you may continue, right? Alternatively you can continue like this. Now coming to one more example. Now coming to this differential equation, let I mark it equation 3.1. so if I want to solve it by variable separation, I may try it, put x by y is equal to some t, or you can put y by x is equal to some v, and you can continue it. Now if I try to solve it by the method of exactness, okay, let it be my m and let it be my n. Now what is my del m by del y? Del m by del y is equal to, this is 0 and this is e to the power x by y. Because of chain rule, it is x by y into minus of x by y square. Okay, so this is equal to minus x e to the power x by y divided by y square. Now what is my del n by del x? Also if I differentiate it, the same x e to the power x by y divided by y square will come out. So therefore del m by del y is equal to del n by del x. So this implies equation 3.1 is exact. Okay, thus the general solution is given by, thus the general solution of 3.1 is given by integration of m xy dx y is equal to constant plus integral ny dy is equal to some constant. So you see here, so this implies it is here 1 plus e to the power x by y integration of dx with y is equal to constant, plus there is in n there is no terms, this is also not free from y and x and also not free from x, so it is here 0 dy is equal to constant. Okay, so that means if I integrate it, it is here x plus e to the power x by y, here y is constant, so here the constant factor is 1 by y, so it will be divided, so it is y into this, and there is some constant, some c2, and it is balanced with this, it will give you some c. Okay, so this is your answer. Now consider, let it be my equation 4.1. okay, so under example 4 I mark it 4.1, or you may write it 1 or anything you mark it. Now you see the degree is 4 here, the degree is 4 here, the degree is 1 plus 3 4 here, and similarly degree 4 and degree 4. So this is a homogeneous equation, and you may try it, put y is equal to vx and proceed, right? And alternatively if it is exact, then it is a quite easy approach. If this is my m and this is some dx is here and some dy is here, okay, dy is here, so now this is my m, so what is here del m by del y, right? It is, so del m by del y is, it is constant and it is 3x square into 2y, 6x square y, minus it is 6xy square, and again you find del n by del x, okay, it is also 6x square y minus 6xy square, this is also here del n by del x. Okay, so now once it is exact, then it is quite easy. Clearly del m by del y is del n by del x, so that means given equation 4.1 is exact. Thus its general solution is now if you try it by this method, then it is quite lengthy, right? By homogeneous equation it is quite lengthy, so this is a better approach. Okay, so now the general solution is, you should always write the formula m xy dx, treating y is equal to constant plus integral ny dy terms independent of x is a constant c1. So that means, so now this is your m, so you treat y is equal to constant here. Now you find in n the term free from x. This is not free from x, this is not free from x, however this is free from x, so it is minus 5y4th, okay, minus 5y4th dy is equal to 0, right? Terms not containing x in n, okay. So this, let it be my c1, okay, constant c1. So now I integrate, so this will be 5x5 by 5 plus 3 y square constant, it is x cube by 3 minus 2y cube constant x square by 2, then it is your minus 5 y5 by 5, and some constant is here, some c to say is c1. Now this two constant is adjusted here, so that means it is my x5 plus 3 x cube y square minus these 3 and 3 will cancel, 5 and 5 will cancel, 2 and 2 will cancel, minus x square y cube, 5 and 5 is cancelled, minus 5 is equal to some c. So this is my final answer. Now coming to one more example, let us solve this example here. Now let us solve this, let it be my equation 5.1, okay. Now coming to the solution, this equation is of the form, the given equation is of the form m r theta dr plus n r theta d theta is equal to 0. So we have to check, this is my m, okay, we have to check del m by the opposite variable, del m by del theta. If we integrate it, r is your constant, it is minus 2 e to the power minus 2 theta, and your del n by del x, del n by del r, what is your del n by del r? You check it, del n by del r, it is 2r, okay, so it is minus 2r e to the power minus 2 theta. Clearly del m by del theta is equal to del n by del r. So that means equation 5.1 is exact, okay. Once you find the exact, you know the solution. So now the general solution is m r theta, treating theta constant, plus n theta, terms free from r, okay. There is no term free from r in n, so it is my 0. Now this, where theta is treated as constant, okay, so I write this, so that this means my r square by 2 e to the power minus 2 theta, and this there is a constant and there is a constant is my c, say, so this implies my r square e to the power minus 2 theta is c 2c, or 2c is equal to, I can write r square e to the power minus 2 theta is equal to k, or 2c is equal to k, say, okay. So this is my answer, okay. So now let us solve one more example. Now coming to the solution of this question, this is my m and this is my n, okay. You try for del m by, this is x, so opposite variable, by del y, this is 0, and e to the power x constant, sin y derivative is cos y, e to the power x cos y, and here del n by del x opposite variable, so e to the power x derivative e to the power x cos y, so this is same. So let it be my equation star. So this implies equation star is exact, Also one initial condition is given here, y of 0 is pi by 2, okay, y of 0 is pi by 2. So therefore the general solution is, thus the general solution is, okay, your integration of 2x plus e to the power x sin y dx, you treat y is equal to constant, plus here there is no term free from x, so 0 dy is equal to my c1. So now integrating with respect to x, treating y as a constant, it is x square plus e to the power x, sin y is constant, sin y, and there is a constant, and this constant merged together is my c, okay. So this is my general solution. Now my y of 0 is equal to pi by 2. Y of 0 is equal to pi by 2. I substitute y of 0 is equal to pi by 2. What does it mean? Means this is my x, this is my y. So x is equal to 0, y is equal to pi by 2. I substitute over here. So this implies here 0 plus e to the power 0 into sine pi by 2 is equal to c. So this is, it is here 1. So sine pi by 2 is also 1. So 1 into 1 is equal to c, implies here c is equal to 1. So you substitute over here. Okay. So now let it be double star. So double star follows, double star equation, double star follows. Okay. X square plus e to the power x sin y is equal to 1. So which is the desired particular solution. Okay. Which is the desired particular solution. Okay. So let me to write some assignment question for you. Now coming to the summary of the discussion. If a first degree first order differential equation is given to you, mxy dx plus nxy dy is equal to 0, you may try it by variable separation. You may see it whether it is homogeneous or not, and also if it is exact, then you should prefer exact, because the exact technique of solving exact differential equation is quite simple and easy. Okay, so you should first try that. Otherwise you can try the other methods, and if not possible, you need some substitution. In the subsequent chapter we will see the integrating factor, which will help to bring this equation into exactness. So in the upcoming lecture I will tell that. In the upcoming lecture I shall tell you the integrating factor, and this factor is multiplied to bring the equation exactness. Okay, so in the next upcoming lecture we will discuss. So now these are some assignment problems. You should solve these assignment problems 1 2 3 4 5. Okay, now at this juncture my appeal to all of you is that if you find that this lecture is useful and interesting, please like and subscribe to this channel. Okay, so this will boost my motivation to upload subsequent lecture for your benefits. So thank you all. Have a nice day.